This is worksheet 2.4, question number 6. I've drawn the graph on the right side for easy reference. So this question first asks you to look at the gradient of a speed time graph to decide acceleration and to describe it. So because it's a 3 marks question, we break it down into 3 different parts. From A to B, we notice, and even to C, we notice that it's decreasing non-uniformly. Why did I write from 10 meters per second square? Because we know that at the beginning, the acceleration of free fall is 10 meters per second square. After that, at C, it decreased sharply before becoming negative. So decrease sharply before becoming negative acceleration. Finally, from C to D, we see that it's a straight line, so constant deceleration. B. Let's do part B. One of the forces acting is the weight of the stone. Weight. How do we find weight? M times G. We know from the earlier page, the question, 0.84 times 10, 8.4 Newton. So this question is nothing difficult. Straightforward. Now, next. The other force acting is air resistance. Where does air resistance? We know that as a stone falls, air resistance is pushing against it, and this air resistance gets bigger and bigger over time, the faster it falls. State at which point is the speed time graph the air resistance is the greatest. When is there the greatest air resistance? We know that that is the place where just before C. Because when it's at C, the air resistance is so big that there is very little resultant force. When you minus this 2, it's almost 0, and that is why you have very little acceleration. Why isn't it C to D? Because that is where the stone has hit the sea and is slowing down as it goes into the sea. So air resistance is before it hits the sea. Terminal velocity occurs when all forces are balanced. State is, does the stone reach terminal velocity when it's in the air? No. The graph does not reach a gradient of 0 before C. So before the stone could reach a maximum terminal velocity, it has already hit the sea. By observing the graph, point C, comment on the density of the stone. We can see that the stone is slowing down, but it is falling continuously falling with a decreasing speed until it reaches a new terminal velocity. This is all in the sea. This is all in the sea. So we know that the stone sinks. So we don't have to write this, but we know that the stone sinks. So comment on the density. The density, how does an object sinks? The stone is higher than the density of the sea. And why do we know that? Because it sinks with decreasing speed. Can you imagine if the stone does not sink, the speed will immediately go to 0 because it does not move anymore, but it sinks. So we know that the stone is higher than the density. Now in the exam, if you don't know how to do this question, what you can do is give it a try. Just write. Even if you write higher or lower, it doesn't matter, because at least you will have a 50-50 chance of getting the question correct.